Okay, I'm going to start off talking about polar coordinates by reviewing what we have done for the rectangular coordinate system. Okay, we should all be really good at understanding the rectangular coordinate system, right? So it consists of two axes. What's this one called on here? The x-axis. What's this one over here? The y-axis. What's at the center? The origin, right? Okay. And if I wanted to describe a point in the rectangular coordinate system, and I wanted to call that point A, it would be, and let's say I wanted to put it right here, it would consist of what? How do I describe that point? Yeah, an x, comma, and then a y. And that basically identifies any point in the coordinate system, in the rectangular coordinate system that I want. That should all be reviewed, nothing new. All right, how does this then compare to the polar coordinate system? Okay, the polar coordinate system starts by having, instead of the origin, the polar coordinate system has a pole. Okay, we call that the pole. It acts like the origin, right? And instead of an x-axis that goes off in two ways and a y-axis that goes off in two ways, it starts off with one positive axis, which we call the polar axis. Not very exciting. The polar axis, and that's located here. So notice that it takes the same exact representation as the positive x-axis. It's basically a ray where the vertex is the pole and it shoots off into the positive x direction. Okay, so we have a pole and we have a polar axis, right? It's also considered the initial side of an angle because we're going to create an angle, right? So I would have another ray, which will be called the terminal ray. So this is my initial. The initial ray is called the polar axis. The other ray is called the terminal axis. And what's created in between there? Well, a theta, an angle, right? So we've created an angle here, an angle theta. So if I want to describe a point in the polar plane, or the polar coordinate system, say like this purple point over here, and I'll call this point A, instead of an x and a y like in the rectangular coordinate system, rather it's going to have over here an r and a theta. Okay, well the theta, we already know what that is. The theta is just this angle here, right? Which is the space below, but what's the r? The r is the distance from the pole to the location on there. So an r is a directed distance. So we label points in the polar coordinate system as r's and thetas and not x's and y's like we would in the rectangular coordinate system. Is this making sense so far, everybody? Okay. A couple of things to note here. Okay, r is a directed distance. Okay, what does the term directed distance mean? It has a direction and a certain distance, right? So r is positive because in the terms of that it's a length, all right? But it also has a direction. So, I know, that's funny. So sometimes we'll figure out what to do if r is negative. I'll show you what that means. But right now, r is a directed distance. So a certain direction and go out a certain distance from the pole. It's a directed distance from the pole, so write that down. From the pole. Okay, and the next thing that we should note is that theta is an angle. That's nothing new there. And there are two ways that we can represent an angle. What are the two ways that we can represent an angle, everybody? Yes, and it can be either in radians or it could be degrees. I know, yeah. Okay, so the angle could be in radians or it could be degrees. So, as a recap, the rectangular coordinate system is x's and y's. The polar coordinate system has a pole, a polar axis, which is also the initial side, a terminal side, and we label points in the polar coordinate system as r's and thetas. So the first thing that we learn how to do is plot points in the polar coordinate system. So, as an example, I'll walk you through this one. Let's say I have the point P, and the point P is located at the spot 3, pi over 4. Okay? 3, pi over 4. Well, the 3 represents what in this case? The r, and the pi over 4 represents the what? The theta. Very good. So we have an r and we have a theta. You always start with the theta. Okay? Always start with the theta. So if you're going to graph this, this is what you should do. All right, I'll pick blue. So I'll put my pole on my page and I'm going to label it. Here's the pole. and I'm going to draw the polar axis. Right? And then sometimes I label it as just PA for polar axis. Now I need to draw an angle theta of pi over 4. Well, we all know that pi over 4 is the same thing as 45 degrees, so I'm going to draw an angle of 45 degrees right here. I'm going to color this in. I'm going to say theta is equal to pi over 4. So far, so good? Okay. Then, from the pole, I go out a distance of pi over 4 on the terminal side, or excuse me, not pi over, a distance of 3 on the terminal side of theta. So, I would count out 3 units. I'll call that 1, I'll call that 2, I'll call that 3. So right here would be the point P, located at 3 comma pi over 4. So that was how you would graph it, put it in the pole. 2 things to talk about in terms of the pole. Number 1, the sign of R is very important. So talking about the sign of R. So there's 2 things you want to talk about when you deal with R. If your value of R is greater than 0, all right, then the point, whatever point you're trying to plot, then the point will be on the terminal side, of theta. So what does that mean? Well, this is the terminal side that I just graphed, and R was greater than 0, so it was on the terminal side, this ray right here. Okay? Yeah, Kenzie. So it's saying if R is greater than 0, so if R is a positive number, like it is right now, then the point is on the terminal side of theta. Okay? And again, this is your initial side. This is your terminal side. Because to create an angle, you need 2 rays, right? So these are my 2 rays, my initial ray, my terminal ray. My initial ray happens to be called the polar axis. And it takes the same exact shape as the positive x-axis in the rectangular coordinate system. Now, what do you do if R is negative? Okay? If R is less than 0, meaning R is a negative number, then where do we put it on the polar axis? Here's what we do. We say this. Then the point will be on the ray opposite the terminal side. Yep, even though the angle's going up, even the terminal side of theta. It'll be on the ray opposite the terminal side of theta. So these are the 2 things to consider for this one. Okay? What if R was actually equal to 0? Where would it be? If R is 0, where would it be? It'd be at the pole, right? So the angle is, it doesn't matter what angle I use because I'm not going anywhere because I'm going 0 distance, direct distance from the point pole, or from the pole. So if R is greater than 0, it lies on the terminal side. If R is less than 0, it lies on the ray opposite the terminal side, even though the angle is what it is. So you always graph these by starting with the angle. I'm going to do some more examples. Okay, here are 2 points. Notice that each one of them is a polar coordinate. So this represents R and this represents theta. And this one, this represents R and this represents theta. Okay, I want to graph each of these in the polar coordinate system. So again, always start with the pole and the polar axis. Okay. From there, draw your angle. 135 degrees would be this angle here. This is the angle theta equals 135 degrees. Okay. The polar axis represents my initial side. The other ray is called my terminal side. R is a value of 2. So because R is a value of 2, which is positive, the point lies on the terminal side of my angle. So I go 2 units in the directed distance on that terminal side, and the point 2, 135 would be right here. That would be point P. You guys get it? Okay. Let's do example B. It says -3, 3 pi over 2. All right, well, I'll do it also in purple. So start with the pole. Here's the pole. Give me the positive, the polar axis. 3 pi over 2. Where's 3 pi over 2, guys? 270 degrees, so that'd be straight down, right? Okay, so this right here, this is a positive angle. This angle would represent a theta of equal to 3 pi over 2. Okay, there's right there. But what do I do with my r? Well, since my r is a negative value, then it is on the opposite ray of the terminal side. Here's my initial side. Here's my terminal side. The opposite ray I always make like a ghost ray. Go that way. So that's the opposite ray. And the point, since r is negative, will be on that ray, the opposite ray. So I'm going to go 3 units and a directed distance of that. So 1, 2, 3. So this is the point Q right here. Weird, right? So no, you don't. Here's the weird thing, right? Is that point could also be described a lot of other ways, right? In fact, couldn't I have just said 3 comma pi over 2? Yeah, 3 comma pi over 2 is the exact same thing. So you're noticing that there are a lot of different ways that we could represent points in the polar coordinate system, whereas there's really only one way to represent them as an individual x, y in the rectangular system. Okay, I have 2 questions in the air. Okay, let's do this one. -1, negative pi over 2. -1 is my r. Negative pi over 2 is my theta, right? So start with the pole. So here's my pole, here's my polar axis, and I want to draw negative pi over 2. Well, which direction do I draw that angle? Clockwise or negative? Or counterclockwise? This one goes clockwise, right? Exactly. So this right here, that represents a theta that's equal to negative pi over 2, right? Now, since r is negative, I'm going to draw my ghost ray, which is the ray that's opposite the one that it's on, and I'm going to go 1 unit in that direction. So that would be this point here. This would be the point S. And that's how you do with it. Okay? Okay, let's do this one. -5 comma negative pi over 4. Okay? So again, we'll start with the pole. And I want negative pi over 4. That would be this angle here. This angle right down here represents a theta that's equal to negative pi over 4. Since my r is less than 0, then it's going to lie on the ray that is opposite the terminal side. So I'm going to go 5 units out. So 1, 2, 3, 4, and 5. There we go. That is the point P in the polar system at -5, negative pi over 4. So look, if I see that I have like all these degrees here labeled, right? So if I wanted to label the point 5 comma 100 degrees, I'd draw my pole 100 degrees and go 5 units out, so it'd be labeled right about here. Does that make sense? So polar graph paper is in circles, right? It's not rectangular, it's polar. Kind of cool looking, right? Okay, here's a you try. Try each of these, A, B, and C. Graph the point in the polar coordinate system. Okay, Tess, what'd you get for part A? So 315 degrees is like something like this, right, all the way around? Yeah. So there's a theta equal to 315 degrees. Then what? And then I counted down. 1, 2, 3. Yep, so I'm going to go 3 units away. So the point would be right about there, and that's how you graph it. Everybody agree with that part? Okay, good. Part B you guys are tripping out on, right? So draw pi. Where's pi? Pi is that one, right? So that angle is pi. So there's a theta that's equal to pi. But then we go 2 units in the opposite direction, so we just end up right here. Is that why you guys are tripping out? Yeah. Okay, good. And then part C, how do that one? So negative pi over 3 is like a negative 60-degree angle, right? So there's negative pi over 3, and I go back the other way. So I draw my ghost one and go 1 unit back the other way, and that would be the point -1, negative pi over 3. Okay? You guys feel pretty good about this right now? Okay, so tonight, you're going to have to do 2 things. They're going to give you pictures of points in the polar coordinate system. You have to give them the r and the theta, and then vice versa. They're going to give you an r and theta, and you have to graph it, okay? If you want to be really cool, go ahead and download some polar graph paper and try it yourself. Okay, other than that, that's day 1.